Okay, so our next piece to our puzzle here in stoichiometry is what we call percent yield. The percent yield is a relationship, and I probably should describe this. It's a relationship between what you do produce and what you're supposed to produce. Or I don't want to say just produce, because it could be how much you need for like a reactant or something. But since we now have on paper a way of determining how much product, let's say, we're supposed to make with a certain amount of reactants. If I've got 10 grams of A, I'm supposed to produce 20 grams of B, let's say, okay? Well, what happens when you do a lab, when you perform a lab, when you put it together, when the thing actually reacts and you're supposed to get 20 grams, but you only produce 18 grams? On paper, it's telling you exactly how much you're supposed to get. There's no loss of anything. When you do it, when you experimentally get it, you might lose some. There might have been, I don't know, splattering. We didn't mask properly. Something got spilled. There could be a whole bunch of different reasons as to why you don't produce what you're supposed to produce. But percent yield is a way of relating those two things, okay? So just understand that a 100% yield, as opposed to when we did like percent deviation, you wanted low deviations, right? Because deviated was how far you are from an accepted value. So if you had a 1% deviation, you were really close. If you had a 50% deviation, you were pretty far deviated. Percent yield, the higher you get, the better you are, the more accurate, I guess you could say, you were. So the formula is simply the experimental yield divided by the theoretical yield, and you multiply it by 100 to get your percent yield. And all that this experimental yield is what you get when you do the lab, or whatever it might be, what you get when you do the lab. The theoretical is what you're supposed to get. And I'm going to put on paper. Calculate. Okay? The theoretically, what are you supposed to get? So that's the experimental and percent yield. So I have an example of a problem to solve. It's pretty straightforward. I say Mr. Marquis started an experiment with 16.5 liters of oxygen. For those of you that know me, you know that I would interrupt myself and write, well, let me just do that here. Get a little bit of room. 16.5 liters of oxygen and excess hydrogen. That means I have so much hydrogen it does not matter how much I have. Okay, I've got plenty of it. And recovered 24.5 grams of water. What is the percent yield of water? That just says recovered. Okay, so basically what I'm saying is, and again I've used the same example here, I've got hydrogen reacting with oxygen to produce water, and I should balance, there I am. What I'm basically saying is I have a certain amount of oxygen. When I react it with plenty of hydrogen, I produce water. Now I get 24.5 grams. That's going to be my experimental yield, okay? What I need to solve for is, I need to solve for how many grams of water I'm supposed to get, okay? And so if what I'm supposed to get is pretty darn close to 24.5, then I was pretty darn accurate with my lab, let's say, okay? So all I'm really doing is a little more stoichiometry, some conversions between liters of one, so I have liters of O2, and I want to convert to grams of H2O. Now, through that step, I'm going to go to moles, then to moles, then to grams. Okay? So here we are. Liters of O2 to moles of O2. 1. It's always 1 when you're doing a moles to liters, grams, or particles. Liters is 22.4. So I divide that and I get 0.73 moles of O2. Now I have my moles. I can convert that to moles of what I'm looking for. In this case, it's water. So 2 and 1 respectively. When you convert moles, you use the coefficients of the balanced equation. So I'm going to multiply that by 2, 0.73 by 2. I get 1.46 moles of H2O. I'll bring that down here. 1.46 moles of H2O. X line. Oops, let me grab a different color just for emphasis here. It's another step. Moles of H2O, grams of H2O, 1 and 18. I look on the periodic table for H2O, and when I multiply that, I get 26.28 grams of H2O. This number right here is my theoretical amount, or theoretical yield. Okay, that's what I'm supposed to get. I gave you, and this would be given in a problem, that you recovered 24.5. So I'm kind of running out of room. Let me go back up to here. 24.5 divided by 26.28. Divide those two numbers and multiply by 100, and I get 93% yield. 93% yield, which is very good, obviously. I pretty much calculated and got what I was supposed to get. So that's percent yield.